Okay, in this lecture we focus on the MCQ number 9 and 10, and before starting I wanted to talk to you a bit about periodic functions. So periodic functions. Okay, what are periodic functions? So suppose, for example, if I tell you, for example, that just that is periodic f is periodic with period 3, it means that after every 3, okay, after 3 centimeters the function repeat itself. So this is to make it easier, let's use periodic of period 2, for example. This is from 0 to 2, right? Then you have 2 to 4, then 6. So how many periods do I have here? This will be the first period because it's length 2, yes or not? Then the second period will be this one, then the third period will be this one, okay, and the last one. So on the suppose that the graph of the function is like this on the first period, on the second period it's exactly going to be the same. So the function repeat itself exactly as, okay, and exactly like this. So, and you will keep doing it like this. This is the periodic function. So the function is periodic if it repeats itself after a period. Okay, is that clear? Okay, so how can we say that this function is periodic with period 2? How can I say it mathematically? To say it mathematically, it just means that f of x will be the sum of f of x plus 2. What does it mean by this? When I write something like this, I mean what happened at the position x should happen at the same thing should happen at the position x plus 2. That's what means that the function is periodic with period 2. Is that clear? Then what happened, I repeat, the function is periodic with period 2 means that what happened at the point x will happen the same at the point x plus 2. Okay, then in general my period will I can have function having period t, yes or not? This length here is t, then maybe you move from t to 2t, and then finally 3t, yes or not? So on each if the function here is like this, on the next period it will be like this, and the next period. So this is what we call, this will be a function with period t. Okay, and in that case the function f of x will be equal to what happened at x will be the same thing at x plus t in this case. So this is what we call definition of function. So we say that f is periodic with period t if what happened at x is the same thing that happened at x plus t. Is that clear? Not something very important. Suppose that f is periodic with period t. So this is from 0, this is t, right? This is 2t, right? This is 3t, this is 4t, 5t. I mean it's sufficient. Look, suppose that on each period the function do like this. on each period. Okay, look, it means that t is the period, right? This it means that f of x, we know that f of x is also f of x plus t. Excuse me, why? Okay, but look also, if I look the windows of 2t, so if I take this windows, then take this windows, does something change between these windows and this? So if you look, instead of looking at t, you look like windows of 2t's, the function is still periodic if I take windows of 2t's. Yes or not? So you can also say that if I wait, the function repeat itself after every each 2t. So also f of x is equal to f of x plus 2t. So what am I saying? I am just saying that if t is the period, if t is the period, let me write it with the right pen. If t is the period, any multiple of t, any multiple of t is also a period. Is that clear? What did we see here? We saw that if t is the period, also 2t will be a period. So when we talk about the period of a function, we talk about the smallest possible period. Because by the way, once I know a period, any multiple of that period is still a period. Is that clear? Okay. Doubts? Okay. Now I will just say that because it's important to know it. Some examples. When you have sine of x, the period of this function is 2 pi. The cosine of x, the period of this function is 2 pi. But in general, if you have like some cosine of ax plus b, the period will be 2 pi over a. If you have sine of ax plus b, the period will still be 2 pi over. Is that clear? Okay. And also remember that the graph of the mantissa, I don't know if we did it together, it was something like this. What do you notice? How much is the period? Is it periodic? It repeats itself after how much time? Yes. So when I have so from this graph we saw that after a step of 1, so from 0 to 1, then from 1 to 2, then and yes or not? After each step of 1, the function repeats itself. And so we know that mantissa, now you know that mantissa of x is periodic, and the period is 1. And the period is t equals 1. Is that clear? Nice. Please now keep in mind that anytime you do f of g of x, this is important. If the internal one is periodic, so if g of x is periodic, okay, f of g of x will be periodic. In fact, it is so if you when you combine them, if the internal one is periodic, then the composition will be periodic, and the period will be, and the period with the period is usually equal to the period of the internal one. For example, if you do sine of mantissa of x, okay, what is the internal one is the mantissa, right? So I expect that the period will be t equal to what? To 1, because we use the, yes or not? So when I do sine of the mantissa of x, the internal function is the mantissa, and the period of the mantissa is 1. So the period of this stuff will be 1. But if I do mantissa of the sine of x, I expect that the period will be 2 pi. Yes or not? Doubts? So going back to our exercise, you can see here that so we have sine of x and we have mantissa of x. Then f of g of x has period 2 pi. F of g of x will mean sine of mantissa, right? F of g of x means sine of mantissa, but the period of this stuff is 1. Yes or not? F of g of x has now g of f of x has period 2 pi. Yes, because it is the mantissa of, if you do mantissa of sine of x, then by the period for you is 2 pi, by the way, right? So B is correct. Look, this is the kind of MCQ in which or you know that B is correct, or checking the order will be very long. I am not going to spend time to check them, because checking them will be, it will take time. You will, okay? So we skip by the way, checking is just a matter of doing computation. So if I do all this computation, it's not going to bring you anything new. It's just doing computation to find the domain of f rho g. The image, typically finding image is not that easy. So, and especially if we are doing, you don't need to do it for nothing. Okay, so that's why I'm not going to do computations. Okay, so I move to MCQ number 10. I hope the short presentation about periodic function was clear, and it will be helpful for you. Okay, so let's move to MCQ number to the question number 10. Okay, the question says that let f from, so you have f that move from R except the null element to R. Okay, the function so f of x is equal to 1 over x. So the function is surjective. What does it mean? What do we mean by the function is surjective? What do you mean by when somebody says that f is surjective? So f of x is surjective. What does it mean that the function is surjective? Okay, we say that f is surjective if and only if the range of f, the range of that function, is equal to R. Is it clear how to find the range of a function? So if the range of a function is equal to R, then that function is said to be surjective. So how, for example, let's consider that I give you a function like this one. You can see how, where do I read the range of a function? The range on the y-axis, right? You see that whatever is any y that I take here, I will find the corresponding. Yes or not? We can say excuse me, we can clearly say that this function is surjective because the range of the function, okay, is from minus infinity to plus. Okay, I mean, this is the roughly speaking, like if I don't want to be formal by giving theorems and stuff, one can just says that yes, the function is surjective if the range of that function is r. Okay, now so you imagine I draw a function like this one. Is this function surjective? One need to look at the range, right? To look at this line. It's clear that all the places that I put in green can match. Yes or not? They match the function, but the problem is here. 0, it doesn't belong to the range, because if I try to touch the function going this horizontal line never touch the function. So the range here is not r. The range here will be the range of f is r except 0. So this function is not surjective, right? Going back to I remind you that the function, you have the function minus 1 over x, okay? And keep in mind that this function that I just drew here is exactly the representation of the function minus 1 over, and we just see that it's not surjective, right? It says then that since f of minus 2 is smaller than f of and f of 1 is smaller than f of 2, the function is strictly increasing on r except 0. You agree that this function is strictly increasing? It is increasing in both sides, but not in all the yes or not? Because when you say that, please guys, pay attention to this kind of statements. Saying that the function is increasing in the, if I say that this function is, when I say that the function is increasing, it means, for example, that f of 2 should always be greater than f of minus 2. For example, when the function is increasing, it means that if x1 is smaller than x2, f of x1 will be smaller than f of, yes or not? But in our case, if I take, for example, minus 1 and 1, you agree that minus 1 is smaller than 1. But if I do f of minus 1, if you go back and you do f of minus 1, you will get minus 1 over minus 1, which is 1, right? But if you do f of 1, you will get minus 1 over 1, that is minus 1. So this function is not increasing, because if it was increasing, the image of 1 was supposed to be greater than the one of minus. Is that clear? This kind of function is not increasing, and it is far from being strictly increasing. So B is false. Since the function is injective, it is strictly monotone. We just say that it's not monotone. Strictly monotone means strictly increasing or strictly, okay. And tell me. No. Okay, the question of my student is to repeat the definition of injective function. Okay, So injective function is what you can say one-to-one. Saying that the function is injective, it means that for to each x, let's say that to each x is associate one and only one y. So let's illustrate. Yes, this function is injective because it is one-to-one, right? To each x you have only one. Okay, if yes, in fact, if you get something like this, to this to the same y, you can have many x, right? So this x, this one, this one. So this if a function like this one is not injective. Yes or not? So an injective function is a function such that if you take x1 and x2 such that x1 is different than x2, then the image of x1 will also be different than the image of x2. Is that clear? So yes, in this case this function is injective, but it's not more. Okay, so the answer is E. Okay. Doubts? Okay, nice. In the next section we will continue with quiz 11 and 12. Okay, thank you for attending.